Okay, so today we're going to look at coding challenge 5.1, Dutch national flag problem. This is actually not a problem, but a way of solving sorting algorithm. So normally sorting algorithms are n log n, right? But with this approach, we could reduce the time complexity to just O of n, right? Okay. And fun fact, this is called Dutch and not Italian or French or German, because of course Dutch national flag has two colors, right? Yeah, three colors, 1, 2, 3. But it's called Dutch because it was invented by Dijkstra, and he's a Dutchman. Okay, cool. Let's get back to business. So our problem states that, let's say we have an input of an array of 3 numbers, right? What we need to do is basically just sort the array. And how to do it is, with this approach, is to have a lower boundary and right boundary. You could just imagine that this is like left boundary, right? And then we have right boundary. And this guy here is moving from left to right with this pointer, right? And for the right boundary, it just go to the left, right? Okay, cool. And so we have 2 pointers as well as 1 runner. So if the number, and we have just need to check if the number is equal to, let's say our pivot is 1. So if number is less than pivot, we need to swap whatever is on the left boundary and move both pointers, right? So our runner is now here as well as left boundary. If current number is the same as pivot, we don't do nothing, no swapping, but just increment our runner. Now we have 0, so we swap 0 with the left boundary and increment both pointers. Okay. Now we have a number that is bigger than our pivot, and we need to swap the current number, which is the same, and just move the right boundary point, right? Okay, cool. So let's implement this in code. As I said, the time complexity for this one, yeah, like we can write it. So time is O of n and space. It's O of 1 because we're using current array. It's awesome. So we have an array and a pivot index. We can store our pivot. We need to initialize few variables. So we have left boundaries, we have right boundary, and we have I as runner. Left boundary is 0. Right boundary is the last index inside the array. So len I minus 1 and I 0. Cool. And then we just, so while I is less than or equal to right boundary, we will be checking and swapping things. So the first case, if current number, which is I, is the same as pivot, we don't do any swapping, we just increment the current I runner. If current number is smaller than the pivot, we need to swap the so I and left boundary, and we can increment both I and left boundary. Okay, and the last one, if A of 1 is greater than pivot, what do we need to do is swap boundary and move the pointer to the left. Okay. We don't move I, because when we do the swapping from the left boundary, we still need to process the number that we swapped from the right boundary, right? Okay, and we're done. So let's just implement this in code and run the tests. So first thing we need to do is we have pivot, which is a index. Cool. So left boundary, right boundary, and I is to be initialized. Left boundary is 0, right boundary is len a minus 1 and 0, of course. So while I is less than or equal to right boundary, we check first if the current number is the same as pivot. And if it is, we just move the pointer I, the runner. If A of 1 is less than pivot, we need to swap with the left boundary and move both left boundary pointers and the runner by 1. And the last thing, and if A is greater than pivot, right, we swap with the right boundary and we move right boundaries to the left. Okay. Let's look if the code looks correct. So we have pivot, we're initializing our pointers. Cool. Okay. Let's run the tests, and they pass. Hope this helped, and until next time, bye.